Okay, I think I am live now. Hello everyone, today we would be discussing Codeforces 943. It was rated for due 3 participants. Before we get started, can anyone confirm if audio and everything is fine? And is it just me or like the Codeforces website is slow for everyone for today? Hello? We'll wait for a couple of more minutes. Like the original start time was 10:35. Hey, hi Rishikesh, you know. So like can anyone confirm if audio and everything looks fine? Hey, hi Nitesh. Okay, thanks, Dark Knight. Audio looks perfect. All good. So I will probably wait for a minute or two and then we will get started. Like, how was your contest, by the way? Like, prima facie, I was able to solve all the problems, but this problem is again proved by AC instead of me having an explicit proof where my code runs in the required time limit. So, like, that's where we are right now. Like, this second contest would have gotten a, like, some people says they have got only A and B. And like, is Codeforces website slow for everyone or is it just me? Like I will probably go from the order A to G2, like the same order, and it's the problem of this week. Was TP along the lines of knapsack, like 1 second, permutation game. No, like we don't need a knapsack here, like we can do a greedy, like the main observation is like after an you have to only go until first an operation. After that you will remain constant at a particular place. So like basically like like if you move n steps forward, you will definitely reach the same cell again. So that way, after n step, you would reach all the possible steps that are possible. And the idea is you will move some steps forward, and then you will remain standing there until all the remaining moves. Yeah, I agree on C. Like C was harder than problem D. Like if you look at my submission order, like the order is jumbled up here. Like so, the way I remember I solved was A B, then I went for D, and then I went for F, then I solved C, E, and then G1, G2. So at least I believe the difficulty, yeah. A, B, D, F, C, E, G1, G2. Yeah. So I think from my side, like that's the difficulty order in this contest. Okay, like I think we can get started now. So like the first problem says maximize. You are given an integer n. Your task is to find any integer y such that GCD of x y plus y is maximum possible. Note that if there are more than y which satisfies this statement, you can follow anything. And then you can notice that t is up to 1 to 1000 and x is up to 1 to 1000 and y is less than x. So the idea is like we try like we try all possible y equal to 1 to x minus 1, we can use built-in underscore GCD function to find GCD x comma y and plus y. And then like we can see which one gets the maximum possible value, and then we directly print. So like I would say it was more of an implementation problem rather than anything else. So like we need two things: LLI Maxwell, which can be 2, and Maxwell, which is 1. Like for y equal to 1, the answer value is 2. Then like first we find value for a fixed I, which would be GCD of x comma I plus I. And then if this value is greater than Maxwell, we reset Maxwell equal to L, and like we set Maxwell equal to I, and then we print Maxwell. And like this was pretty much the solution I had for this problem. Is it just like someone is asking if k divides x, then maximum y will be GCD of J, maximum with GCD equal to k is x minus k, so we just print x minus 1. No, like this can definitely be false. For x minus 1, the value is n. Okay, like this looks fine to me. Like GCD printed x minus y. I don't know why this works. Okay, so the another observation which we can make, like if is like this value like GCD of, like if we fix the GCD, then the largest number, and let's say like because let G be the GCD of x comma y. This implies that x divides G divides GCD, G divides x, and like if we look at all the multiples of G here, there would be G, 2G, 3G, and there would be some x, and there would be some x minus 1. So if we pick this number, and if we pick this G, then the G plus GCD of G comma x minus G would be G always. If J is less than equal to x. And like the important question is, probably it can be an homework exercise, like why this equation holds. And like if we look at the multiples of a particular G, and then if x and x minus G is the largest possible Y here. So that way we can claim like the maximum possible value of this expression is always n. Is always x. And if we know the maximum possible value of expression, you can notice that GCD of x minus 1 comma x is 1, and 1 plus x minus 1 is also x. So like that is an alternative solution that will work actually. Like we can always print x minus 1, and that would be an AC solution. Like it was a neat observation, I would say. Like at least I did not realize this until someone in the chat pointed out. X minus 1 works. The important, like the difficult part for this problem would be to prove why x minus 1 will work. And any more questions on this one or any other ideas before we move to the second problem? Okay, why x minus 1? Can you explain me? So there are multiple parts to it. Let's say we have some particular value g. Like let's call it g, not like, let's call we have some particular value I. One thing you should notice is that if I comma x, where I is less than x, then this GCD value would be less than equal to x by 2. This would be first thing you might want to prove it. And then like another thing to notice here would be, if x modulo I is 0, then if you look at the multiples of I, 2i, 3i, 4i, x would be one multiple, and the largest multiple which is less than x would be x minus I. If I divides x, then if you look at the multiples of I, like there is some noticeable lag. So basically the idea is if you choose y equal to x minus I, then GCD of x comma y would be I, and I plus y is x. So like the maximum possible value is always x over here. Now the drawing explanation is in fact lagging. Like I did try switching my network, but yeah, it's not just. So like value is x, and the next thing to note was like for y equal to x minus 1, this value is in fact x. So like there are three parts to it. Like first, realizing that the maximum possible value is x, and then for x minus 1, this maximum value is in fact x, and that's why this x minus 1 is working here. And the main idea was like if we pick some number I, and if I divides x, then the largest multiple of I which we can take would be x minus I. And GCD of x comma x minus I would be like in the first step. Now you would take mod or whatever you want, you would get I comma x in the next step. And because I divides x, this would in fact turn out to be I. And like this was pretty much, I think this was the main idea for this problem. Like I would say nice troll problem, like where like a lot of people might have, yeah, like the problem, like it was problem, and like in fact I also brute force for all the values that were possible there. And second problem says prefiquence. You are given two binary strings A and B. A binary string S is a string consists of characters 0 and 1. Your task is to determine maximum possible k such that prefix of A of length k is a subsequence of B. A sequence A is a subsequence of B if A can be obtained from B by deleting some characters over here. Like the main question here would be like probably like what does the problem statement mean? Like let's first take some samples. Yeah, like maintaining two pointers was the idea for this problem. Like first let's look at the samples here. Like first sample is 1 0 0 1 1, which is A, and B is 1 1 1 0. So you can notice like the answer size is 2, like these two characters are possible, and one possible way would be picking up these two characters, and like, and you can notice 1 0 0 is not possible if you delete some characters from B. And like probably let me take one more example here. In the fourth sample, like let's pick 1 0 1 0 0 1 0, and let's pick b equal to 1 1 0 1 1 1 0 0 0 0 1. Here you can notice that like this is the string possible, which can be obtained by taking this character 1 0 0 and 1. So like if we take these characters, we can get this as a possible string. So the main idea is like if we have some characters like a0 a1 a2 a3 a4 up to some let's say an minus 1, we have b0 b1 b2 b3 b4 up to bm minus 1. If first two characters are equal, then we can find the maximum answer for this part and then add +1 to it. If first two characters are equal, and if first two characters are not equal, because whatever string we form, like first character must be there, and if first two characters are not equal, then we can delete this character and then we can try to find the answer for this part. And like this was the idea for this problem. Like there are many ways to do it. You either do it recursively, you do it iteratively, however way you want. Like if first two characters are equal, you add 1 to it and find the answer by removing the first character of both the strings. And if first two characters are not equal, you remove the first character from B and try to find the answer again. And like that's what some people have mentioned is known as two pointers here. Like I start with the first two characters while I is less than m, and like I have not processed both of the strings. If si equal to ti tj, I add continue, and if they are not ignored, then I should ignore the current first character and I can do j plus plus. And like this would be the idea for this problem. Any questions on this one before we move to the next problem? I just looked the frequency of B and then looked over A and maintained a frequency while frequency of answer was, and I kept increasing K. Why is this giving wrong answer? Like this fails on this counter test case. Let's say A is this and B is this 1100. Here the answer is true. Like this is the only match here. The problem here is like we cannot rearrange the characters of B. Characters was allowed. This would have worked. Or probably the other solution, like if this is not where your solution fails, then this can be the other place where your solution will fail. The answer is also 4 in this case. And you might print 6 here, and with 6 is wrong here, 4 is the correct answer. 4 nahi, in fact, 2 is the correct answer here. Like these are the only possible matches here. No other. So like this can be these two can be the counter test cases. You can try running your code on it, and if it doesn't work, so you might want to share it on the Discord server. So I will move to the next problem then. Assembly via reminders. You are given an array x1 to xn. Your task is to find an array a1 to an, where 1 is ai, all ai's are between 1 and 10 power 9, and xi equal to mod ai minus 2. And like there are some examples given, and it says like if more than one array satisfies, we can print any of them. Like there are no construction. Yeah, binary search also works, but the problem is when you binary search, your like checker function would in fact essentially do what we are doing here. So like the first idea I had was also binary search, but yeah. So like let's look at like examples of the third problem first. Says 2, 4, 1 is given to us, which is x. First x1 is not there. And sample example is 3, 5, 4, 9. So if you notice here, like 5 mod 3 is 2, which is same as this. 4 mod 5 is 4, which is same as this. And 9 mod 4 is 1. And this one is same as this. So there can be many, since it's a constructed problem and it asks us to print any possible array, there are many possible solutions for this one. And like I will share one solution which I was able to find over here. And like my solution was, like let's say we want to find x mod y. And if y is greater than x by 2, then x mod y is simply y minus x minus y. It's a bit counterintuitive, but the way to look at it is like how do we define, like let's say we have an array of length x. We first have an array of like what is x minus 4? X mod y. Let's say we have an array of length x, and the way we find mod is like we first take an array of length y from here and delete it. Then we again take an array of size y, delete it. Then we again take an array of length y, we delete it. And then there would be a point when the remaining part is less than x mod y. Here this leftover size is x mod y. Like does this, like this is probably one intuitive way to do it. And now we like, if y is greater than x by 2, then you have this as an array x. But let's say y is also less than x, because otherwise the whole segment is there. If this holds, then like when you will try to find array, like the first half would be y, and the second half would in fact cross the value of x. So like this area would be x minus y, which is also equal to remainder, which is equal to x mod y. Does this make sense? Like if y is greater than x by 2 but less than x, then x mod y is nothing but x minus y. Any questions on this observation first before we try to solve this problem? Like once we realize this observation, if this is what holds, then the next thing I did was like I can start with array a0, a1, a2, a3, a4 up to an. We have x2, x3, x4 up to xn. I first this as 10 to the power 9 maximum possible value. Okay, like my main claim was like if y is if we want to find x mod y, and if y is between x by 2 and x, then x mod y is x minus y. And the reason for this is like, if we look at visual proof of what is x mod y, the way to look at it is, let's say we have a wooden stick of length x, which is in pink color here. And if we keep cutting the wooden sticks of length y, which are in length blue length, we would be able to first complete some of the chops here. And then there would be a time when the remaining part is less than y. And that remaining part is nothing but the definition, like value of x mod y here. And like if we similarly, like now if we similarly look at, like if x is less than y but is more than, sorry, if y is more than x by 2 and less than x, then like if we try to take a string of pink length of string of length x, we would be able to chop the first string of length y, and the second string would be outside the boundary. And if we even look at this, the value of this length, this is x minus y length here. So that's why if this condition holds, if this condition holds, then x mod y would be this. And like once we know this, the way like I did was, like if we I marked a and as 10 to the power 9, the maximum possible value. And the way I did it was, like I took the second value as 10 to the power 9 minus xn, because xn is between 500 and 1. This 2 into 10 to the power 9 minus xn would be greater than 10 to the power 9, and 10 to the power 9 minus xn is less than 10 to the power 9, because all xn are positive numbers here. And like this was how I recursively found the solution. Once I knew the value of an minus 1, I subtracted xn minus 2 again to find the next value. And like this was the idea I had for this problem. Like any questions or anything, something which is not yet clear for this problem? And like someone in the chat was like, and like that can be the other solution. Like we can take first number as 501, and then we can keep adding xi to it to get the final value. That is essentially the reverse way of what I did here. Like any questions or something which I should repeat again on this problem? Like I found this problem harder, so like I'm not really sure, like in the first go people would have understood like what I tried to explain here. So like I would be happy to explain it once again if something is not clear yet. Explain with example? Sure. Like let's pick this example 4 to 5. These are the value of x. These are a. The idea was, if we take this as 10 to the power 9, then my claim was this is the value, right? So I can say this value is 10 to the power 9 minus 2. And now you can verify that 10 to the power 9 mod 10 to the power 9 minus 2 is 2. Because like you can write 10 to the power 9 minus 2 plus 2 mod 10 to the power 9 minus 2. And like this part will cancel out. And like whatever remains would be 2 mod 10 to the power 9 minus 2, which is in fact 2. And now once we know this value, my claim was like the other value would be subtract minus 1 from here, which is 10 to the power 9 minus 3. The idea is, like if you look at 10 to the power 9 minus 2 mod 10 to the power 9 minus 3, you can write this as plus 1 minus 1 here to make it 10 to the power 9 minus 3 plus 1 mod 10 to the power 9 minus 3. This part will go away because like this is, we are taking it as mod. So this remaining part would be 1 mod 10 to the power 9 minus 3, which would be again 1. And now if we have 5, so I subtract 5 from here to make it 10 to the power 9 minus 8. And if you verify again, 10 to the power 9 minus 8 mod 10 to the power 9 minus 3 would be 10 to the power 9 minus 3 plus 5 mod 10 to the power 9 minus 3, which should, this part will go away because we are taking mod, and this would be 5 mod 10 to the power minus 3, which would again be 5. And like that was the idea for this problem. This one would be 10 to the power 9 minus 12, which is minus 4 from here. No, wait. The next value would be minus 2 from here, which would be 10 to the power 9 minus 10. And the next value would be minus from 4 here, 10 to the power minus 14. And like these are, this is one possible value here. So like this can be one working example. Like any more questions on this one before we move to the next problem? Okay, any more questions, or I will move to problem D then. Okay, moving to problem D. It says Bordia and Sasa found a permutation P1 to Pn and an array A1 to An. They decided to play a well-known permutation game. A permutation of length n is an array consists of n distinct integers from 1 to n in arbitrary order. Some definition of permutation is given. Basically the permutation is like all the values from 1 to n should be there. And like, okay, I will work out with the example to explain more what the problem statement is asking. Both of them choose a starting position in the permutation. The game lasts k turn. The player makes moves simultaneously. On each turn, two things happens to each player. If the current position of player is x, his score increases by x, and then player can decide to stay at x or move to some other the value which is p of x. The winner of the game is with a higher score after k turns. Knowing both their starting position and Sarsa's starting position, determine who wins the game if both players are trying to win. Let's first forget how to find who is winning. Let's first see like what is the game which is happening here. Okay, I will take first example. First example, it says given values of A are 4, 1, 2, 3. No, basically the given P is and the given values of A are 7, 2, 5, 6. And let's look at Bodhia. Bodhia's initial position is given to be 3. So like let's look at it like a platform where there are some points here. First position, 2 position, third position, fourth position. Bodhia is at position 3. So in the first run, Bodhia will get 5 points. And either Bodhia can decide to remain at position 3 or it can go to new position P3. And P3 here is 2. So the idea is like if Bodhi is at index 3, it will first get 5 points, and then it can either remain in position 3 or it can go to position 2, whatever place it wants. And like if let's say Bodhi decides to move to position 2, then she would be here after the first turn. And now when second turn starts, he will get 2 points. And either he can remain at position 2 or he can go to P2. And the value of P2 is 1 here. Equal to 1. So basically, like if this person is at 2, he will get 2 points. And then he have two choices: either remain at the same position or go to position number 1. And let's say he decided to go to position 1 here. Then in the third turn, that person will get 7 points. And then he has two choices: either remain at first position or go to P1 position. And P1 is 4 here. So basically the person has choice: either remain at first index or go to index 4. And that is how the game is playing right now. Like any question on the problem statement itself, like what is happening here? Like the idea is like each person is at, if we look at all the position as some rooms here from 1 to n, if we have rooms marked 1 to n, then what we have been given is like there is a one way road which goes from room I to room Pi. So basically if we have 4 rooms, 1, 2, 3, 4, then P1 is 4. So there is a one-way room path which goes from 1 to 4. If P2 is 1, then there is a one-way path which goes from 2 to 1. If P3 is 2, then there is one-way path which goes from 1 to 2. And if P4 is 3, then there is a one-way route which goes from 3 to 4. So like whenever a person is at some room, he will get the points for that room, which would be AI. And then either he can remain at the same room or he can go wherever the path goes. So like any questions on the problem statement itself, what is happening here? Before we try to find whether game is someone is a winner, draw, or something, whatever we want. So like once we know like how the game is playing, then like there can be multiple ways to do it. The first observation was both players will play their own game to get maximum points. Because in a particular player's turn, like they cannot stop other player to do whatever they want. Because here, like it's not written that two players cannot be in same room or two players cannot be in different room or anything. Nothing like that is given to us. So both the players will try to find the maximum possible values they can get in the K moves. And at last, what we have to do is compare what was the maximum possible value we can get over here. So like if I look at my code, what I did was I took everything as input. Then score one of the first player is, if someone is standing at S1, they have K moves, what is the maximum distance they can go? Score two is, if someone is at position S2, what is the maximum distance they can go? And based on their relative order, we are directly printing the values here. So the problem reduces to, we are in room I and we have to go K steps. What is the maximum we we can get? Any questions so far here before I try to solve further? So like the idea over here is, like, if we look at all the room paths, they would be like this. One room will go to some other room, it will go to some other room, it will go to some other room. And after some point, a cycle will start appearing. And then remaining terms would be like this. And the way someone will play, like, what we have to do is, like, the way it would be played is, like, someone will go to some distance first and in some moves, and then they will stop there for the rest of the move. Like, someone will go some distance and then they will stop there only. So what we can try out is, we can try, like, after each step, what is the score we have got so far and what can be the score we will get if we remain standing there. One, 2K, we move forward J steps to get score so far, and then add K minus J into a current to our score, and at last take maximum on all possible strategies here. So like a brute force way would be, if someone's starting position is S, they take up to J moves, current score and there is some best score as well. We add like current value to current score, and we say best score is whatever best score is so far. And if we remain, if we are at current score and we remain standing at the current position for the rest of the move, and like if we decide not to stay here, then we go to the next possible position, and at last we return whatever the best score we have got. The only problem here is, like, this K is up to 10 to the power 9, and like it will definitely get a TLE. So the other idea was, because our graph looks like this, our graph looks like after that some cycle starts repeating. So like after n moves, we will reach same index again. So like if let's say if stopping here was the optimal way, then after going through this path we will reach again here. Either sum of these is greater than like the length over here into k times the current score. In that case, like we should find the max here in the remaining path and just remain stopping there, or it will not be. So like the next thing was like it's never optimal to go walk more than j steps here, because after j steps we will have definitely reached whatever the state we wanted. And like this is the idea. Like I took p s1 sk s1 s2 as input to make it zero based indexing. X minus a is there. I have best score function which takes some starting position and finds the maximum score using k moves. Then I find the score of first player, score of second player, compare them to print who is the winner. And when I am trying to find the score of a particular starting position, I move at max n steps or at max j step, whatever be the case. I keep a count of what would be the score if I move to the next block for all the first j steps. And for after each step, I try to count like what can be the maximum score I can get if I just stop here for the remaining moves. And at last, st equal to p to go through the next moves. And like this is the idea I have. Any questions on this one before we move to the next problem? Like the problem is like this is iterative. Like DP state, we are not really sure how we would try to do. Like the number state would be k into n for the DP, and like that would definitely get a TLE. Was able to solve G1 but didn't understand E. Like, is it clear now? Like, basically, the problem statement was not clear, or you didn't know how to solve it. What was the idea? Yeah, problem was unclear. Yeah, that was like there are way too many technical terms in today's contest. Like first problem started with introducing GCD, second problem say started with subsequence, etc. So like this was the idea, and like I will probably move to the next problem if there are no more questions on problem D. So like recursive might be possible, but DP I am not sure. Like the problem is like main observation here is you should go towards some step and then you should stop there for the remaining moves. And if you do anything else over here, then the constraints are too high for you to do anything else. And if this is the observation you have, then you don't really need recursive or repeat. You can do it iteratively. Correct. So like that was the idea for this problem. Then I will probably move to the next problem. What if each are in separate cycle? It's definitely possible. So like the idea is like one player cannot influence the other player here. So what we try to find is what is the maximum score a player can get with some starting position, and it does not care about the where the other person is. So like if you look at this function, it nowhere takes the other person's value as input. So even if they are in some other cycle, they try to find what is the maximum score they can get, and then we compare it at the end of the day. Like for probably I can look at the test case it. like k is small, but n is also large. So n into k is definitely very high, and it's a draw at the end of the day. So I will move to problem E then. Problem is a cells rearrangement. You are given an integer. You choose some cells, n cells in this grid. Let h be the set of distinct Manhattan distances between any pair of cells. Your task is to calculate maximum size of h. Examples of set and their constructions are given in the note. If there exists more than one solution, you are allowed to output any of them. And then these cases are given. Okay. So like if you look at the examples, like examples are really nice here. Like I wish there was a way to draw over here. So like in the first example, like let's first forget n equal to 2, 3, 4, because like we can directly hardcode these three answers for the 2, 3, 4. Let's try to solve when n is greater than equal to 5. Okay, like when n is greater than equal to 5, what are the distinct Manhattan distances possible? Xi minus xj absolute value will be less than equal to n minus 1 and is greater than equal to 0. Yi minus yj is less than equal to n minus 1. So Manhattan, if we sum of these up, xi minus xj plus yi minus yj is greater than equal to 2n minus 2. There are n plus 1 distinct possible values. 2, 2n minus 1. Like these are the, and like if we can find a set which gets all of these values, then that would be our answer, right? So like if we can find an answer which has all 0 to 2n minus 2, then that is the maximum possible. And like let me, now the main idea here was to look at analyze the sample test cases here. One second. I'm trying to fetch a whiteboard first. 1 second. I hope the screen is visible. Like what? Like if we look at this arrangement, right? Then like if we took the same two cells, or like probably 1 second, it's better. I can just copy paste this drawing here. Mhm. One second. Okay, let's just copy paste this image once. Mhm. Let's copy this. Like this is perfect. Okay, like probably I will just move mouse here. Like let's look at what are the possible distances here. Like if we pick the same cell, the distance is 0. Or probably I will draw it once here. This is the 5x5 grid we have. Where is this man? Yes, I'm right. Like this is the 5 cross 5 grid I have. 1 2 3 4 5 1 2 3, and it in the example it says this cell is taken, this cell is taken, this cell is taken, this cell is taken, and this cell is taken. One thing to note here is like we must choose this cell and this cell, the one in the color pink, because they are the ones which have distance of 2 and minus 2. You can probably take these two as well, but the situation is same. And after that you see like if we take the same cell, the distance is 0, so 0 is always possible. Here the distance of 1 is there. Here distance between them is 2. Distance between these is 3. And if you notice this cell, the distance here is 8. And because the distance here was 1, you can notice the distance between this cell is 7. Because here the distance was 2, the distance between this cell is 6 here. And because the distance was 3 here, the distance here is 5. So you notice if you choose the first and last cell, whatever distances you have got, maximum minus that distance will also be possible. So now once we look at it, what we can do is we have some grid. We first must take first and last cell. And now if we take all of these cells, here we will get distance 1, 2 from the origin, 3, 4 and up to 0 to n minus 2 would be possible. And all of these cells from here, like all of these cells would be a distance of 2n minus 2, 2n minus 2 minus 1, and so on up to 2n minus 2 minus n minus 2, which would be n minus 2. So if we take all of these cells and we take this cell, then we would be able to get all the possible Manhattan distances here. And the only problem here is like these are n cell and this is n plus 1 cell. So the next idea was to try to figure out some changes in this arrangement to get n cells and all the distances. And the way I found it was, if this is the grid, I will take this cell, I will take this cell, and I will take this cell. Like this can be a long chain here. Like let's say there are multiple cells here. These 3 cells I will take, and apart from this, let me see what I took. Apart from this, I took these as the cells. Like basically, I took these n minus 2 cells first. N minus 2 cells from here. Or n minus 3, I think. Yes, I took this n minus 2 cell, I took this cell, and I took this cell. And the problem was to realize that all the possible distances would be possible here. because these are the n minus 2 cell. If we take this cell and any of this cell, we would be able to get from 0 to n minus 3. And similarly, this cell and this cell would be at a distance of 2n minus 2 minus I, where I is between n minus 3 to 0. And the only remaining distance over here would be n minus 2, n minus 1. 2n and n. Like basically, if we take n minus 2 cells from the first row, if we take this cell, we would be able to get all the distance except these distances. And like for these distances, I took the second cell from here. First is empty, second cell. So that this distance is n minus 2. This distance is n minus 2. This distance would be n. And anything more? And like this was essentially the solution I had. Like you can probably verify it over here. Like any questions or anything on this one before we move to the next problem? Like basically this solution works for n greater than equal to 4. And for anything less, I directly copy pasted the samples. Like n equal to 2, 3, I just pasted them. And I took the first cell, I took the last cell, I took the first row to get all the remaining cell except one, and n comma 2 was the other cell I took. And any questions, like it was more of an observation pattern where you can try to find an you try to put whatever all you can get. TLR is n minus 2 cells from the first row, last cell from the second row, last cell, and the last cell here. And like this would definitely give us all the cells. This was the solution I had. 1 comma 1, 1 comma 2, and I comma I from 3 to n. Yeah, other people have different solution. So any questions or anything, like it was more of an observation pattern where you try to find some different pattern and try to do something over there. And the hint for me was to try to analyze the samples and see like what all possible distances are possible. And any questions or anything on this one before we move to the next problem? Okay, diagonally cells gives all the even distances. We need one displacement to get odd distances. And using this, there are many patterns. Yes, I agree with Dimitri here. Like basically, if you choose all I comma I, you would get all the distance of 2k from. And if you try to move one cell around, you would be able to get other odd distances as well, because you get once you get one odd distance, or plus 2 plus 2 plus 2 would come up. And like that was probably like there would be many other solutions. This was one which I was able to find. So any questions on this one before we move to problem F? Problem F says equals XOR segments. Let us call an array x1 to xm interesting if it is possible to divide the array into k equal steps where k is greater than m, so that bitwise XOR of each of the values of each part are equal. More formally, you must split any split array X into k consecutive segments. Each element of X must belong to exactly one segment, and let y1, y2, yk be the XOR of elements of the each part, then all the parts must be fulfilled. For example, if X is this, you can split it as follows. Like 1, 1, 2, 0, 2, 3, 0, we can split 1, 1, 2, 3, 0. The first part of XOR is 1, second is 1, third is again 1. So like all the XORs are equal. You are given an array A1 to N. Your task is to calculate answer Q queries. For fixed L2 are determine whether the subarray AL to AR is interesting. So like there are many solutions for this one. Like the main observation was either we will divide the array into two parts or the three parts. Not more than that is required. The idea for this comes from the fact XOR of two equal numbers A XOR A is always 0. So let's say if you have 5 segments, each of them with XOR A. If you merge these two segments, you will get XOR 0. And then you can merge this segment with the third segment to get XOR A again. So as long as there are more than 3 segments, we can basically, if we pick 3 segments here, we merge them, the XOR remains same. So like always check for k equal to 2 or k equal to 3. Because XOR of, if we have 4 segments, then if we pick any 2 segments, the XOR of them would be 0. And we can merge it with the third segment to get only 2 segments again. Let's say if we have 4 segments of length A, and if we merge these 3 segments, we will get one bigger segment of XOR A. And like that is the idea I had. Any questions on this observation first? Like we should only check for k equal to 2 and k equal to 3, and rest everything will follow. Like the next part was, if we have some XOR for each of the segments. No. So like what I say, let's say we have 5 segments. 1, 2, 3. Like we have this segment which has XOR 4. 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 Now if we combine these two segments, if we combine the first two segments, then this XOR would be 4 XOR 4, which would be 0. And now if we again combine it with the third segment, like the XOR of these segments will again be 4. So you see, if you have more than 3 segments, then you can take the first 3 segments, combine them, and you will get one bigger segment with the same XOR value. So for example, if we have 5 segments, we take the first 3, we combine the first 3 segment, we would get 3 segments with same XOR value. If we have 10 segments, if we take the first 3 segment, combine them, we would get 8 segment with the same XOR value. And if we take in these 8 cells, if we take the first 3 segments, combine them, we would get 6 segments with equal XOR value. From 6 to 4, 4 to 2 we can get. This way we would be able to get it. So like if there is a way to make 11 segments, then there would be a way to make 3 segments as well. like, does this statement looks correct, or any questions, or like why this should not hold? So that way my claim was like, if we are able to get odd segment, okay, makes sense. And now like my only thing I was checking was k equal to 2 or k equal to 3. Yes, so we are trying to split the array into 2 or 3 segments with equal XOR value for each segment. Yes, that's what I am trying to do. Because if is a way to get 5 segments, then I can combine that for the first 3 segments to get a solution for 3 segments as well. Or if there is a way to divide the array into 10 segments of equal value, then I can combine the first 3 segments to get an answer where there would be 8 segments of equal values. And in this answer of 8 segments with equal value, I can again take the first 3 segments, combine them to get a possible answer for 6 segments as well. Although 6 to 8 does not holds, but 8 to 6 definitely holds. And like that is what I am trying to do, to say like all we have to check is k equal to 2, k equal to 3. Because if a solution exists for 10, then we can keep deleting segment to get a solution for k equal to 2. Or if a solution exists for 51, we can keep combining segments to get a solution for k equal to 3. K equal to 1 is not allowed, otherwise we would have combined 3 to 1 as well. So this was the main idea. And now like let's first forget the sub array queries. Let's just look at the original segment only. So let's say we have an original segment and we divide it into 2 segments of equal value. This is A, this is A. Then what is the overall XOR possible here? Total XOR would be A XOR A, which would be 0. So if the complete array has a XOR of 0 and length at least 2, then it's possible to divide it into 2 segments. So my claim is if the length of array is greater than equal to 2 and if total XOR is 0, then the answer is yes. Because if there is an array with 2 segments of equal value, then if you combine them, you will get XOR 0. And other way around, if overall XOR is 0, then if you pick the first element out, x, then the answer for the remaining part would also be x. Because when we combine them, the XOR is 0. So this is sufficient condition to make XOR 0. So like if sufficient condition to check if there are 2 segments or not. Any questions on this one? Yes, like the first half is XOR 0. So this is sufficient condition for k equal to 2. Let's see how does k equal to 3 looks like. This would be some segment with XOR A. This would be some segment with XOR A. This should be some segment with XOR A. And if you look at the overall XOR, overall XOR would be again A. Because when we combine these two, we get 0, and then we add the third one, we get A. So like if the XOR of overall segment is A, then we need 3 segments with XOR value A. And there is no other possible value for the equal segments here. because when you combine three segments of equal XOR value, you get the same array. So if you divide three equal segments, then whatever each of them should have the value equal to the XOR of the complete array. Like, does this make sense, or any questions on this one? Like, if overall XOR of the complete array is A, now we have to find, can we divide it into three arrays where the XOR is A? For XOR for each of them is A. Yeah, XOR for whole array would be A for three segments and 0 for two segments, yes. So like what we can do is, like, we can first look at to get value of A, which is XOR of complete segment. And now we need to check if we can divide it into three segments where each of them XOR is A. Yes, for the thumbnail service, probably you can hit me up on LinkedIn once. LinkedIn or Discord, anything will work. Yeah, like definitely I need better thumbnails. So like first we find the XOR of the complete segment, which is, let's say, sum A. Now we need to find whether we can divide it into three segments with XOR 0. So the idea is, like, now let's look at the prefix XOR here. And the brute force would be greedily try to find the first segment with XOR A, then remove it, then again try to find greedily with XOR A, and whatever will remain will always be XOR A. Find smallest I such that XOR of 1 to I is A. Take it as the first segment. Then greedily try to find one more where XOR of I plus 1 to J is A. Like, find the smallest I, find the smallest J, and then whatever remains, like remaining of XOR will be A. So like this is the solution. So like this is the idea. Like greedily trying to find the first index where if you cut you will get XOR A. Then try to find the next index again where you will get XOR A. And the remaining half will also have XOR A, you can verify. So like this is the idea. And like this would be the solution if you have to solve for the complete array instead of subarray. Any questions on this one? Before I solve for the subarray part, queries part. TLE is a different thing, but like this should work. Like what I defined A as A was the answer for XOR of all the values of the given array. Like I should have taken a different variable name, but yeah. Like my first thing was, like, let's say we are able to find some segment where XOR of all the values is A. Then the idea was, like, if I combine all three of them, I will get one bigger segment with XOR A. So like if I want to divide in three segments, then the only possible solution would be when each of them has XOR equal to the complete array. So that's how I was able to first find what should be the XOR value when I want to divide it into three segments. That was the first part. And once I know, like, what is my candidature value of XOR for each segment, Then I greedily try to find the first segment, then second segment, and whatever remains would be third, and it can be verified that that is the solution. So the next bit is like this definitely gives TLE, but that would is where the next optimization will come up. But yeah, this was the first part. Now the idea is like we can convert the problem into prefix XOR. We can first compute prefix XOR, which would be like prefix XOR ith value would be XOR of a first I elements of A. So here if you look at it, the prefix XOR of the first part would be pref I XOR pref 0. The prefix XOR of second part would be pref j XOR pref I, and this would be pref n XOR pref j. So like now that is the idea. So the next thing is, if we want to solve for L2R, we already have prefix XOR. We can find our value of A, which should be like the XOR of complete segment, pref R XOR pref XOR L minus 1. If A is 0, directly print yes, because it's given that the value is at least 2 here. R is less than L for all the query. So we don't have to check length 1 check. And if A is greater than 0, then you see like if you start from L and go up till some I, then like what you need is what you need is pref I XOR pref L minus 1 equal to A. And you can run it around to get pref I equal to A XOR pref L minus 1. So we can find like what would be the ending XOR for the first segment. So the problem reduces down to find smallest I greater than equal to some L such that pref I equal to some K. Like K can be variable, and in that case I will choose K equal to this value. Like can we somehow find the smallest index I which is greater than equal to L such that the prefix I for all the complete array is some given value K. Like K I can make it variable there. So like this would be that is how like we can get. The way to find it would be like you can maintain a map with indexes and use lower bound there, or yeah, that would be one way to do it, or probably coordinate compression. Like there are many ways to do it. Like I will say when I am looking at the code, like how we can use built-in lower bound function to get this value. And once we know this I, what we know is pref j or pref I is A. So find lowest j, lowest index greater than equal to I, where the XOR is A, pref j is pref I XOR A. And yeah, like that is two-part solution for this one. Like first we find like the small, like once we know pref I, we can try to query like what is the smallest index I greater than L with the given XOR, which would essentially be A XOR pref L minus 1. That's how we will find I. Then we can also find j in the similar technique. Yeah, like for that part, I will jump onto the code rather than anything else. Like less than linear time is something I will show in the code rather than trying to solve it over here. This is problem F. Like first I find pref job. I have taken as input. Then for each possible job pref, I can also maintain pref or index. Like for each possible job, what are the indexes where that prefix or exists? Now I will write function get next index required pref or, and it will give me the smallest possible index which is greater than L and which has this required pref. So I can first find all the indexes where this prefix or exists. If required or does not exist, let's just return infinity here. Yes, map plus binary search is what I am trying to do. Otherwise, I can take it vector using reference. Like here, this and is really important. Ref XOR. Now this V contains all of my required XORs here. I can now use upper bound method. To find the first index which is greater than L in this array. If it is v dot n, then there does not exist any such index. Otherwise, we can return star it, whatever value is there at that place. Now, when I'm trying to solve for the queries, like required A, which would be XOR of complete segment. If required XOR is 0, I am directly putting it yes. You can also say R minus L. You can also check R minus L greater than equal to 2, print yes. Otherwise, print no. But the thing is, it's given in the problem statement that L is less than R. So like this condition always holds. Constant LLI get next A XOR pref XOR I minus 1 L minus 1 and the smallest index greater than L with that XOR value. Like in fact this should be lower bound only. Because I am taking L minus 1. If I is greater than R, see out no. Otherwise, I try to find j greater than I. Let's just call it upper bound here. And we will have to pass on -1 here because I equal to L is allowed. In that case, it means that the XOR first value is given required XOR. If j is greater than equal to R, again output no. Otherwise output yes. And like this is the solution for this problem. First we check 2. If there exists, like if the XOR of complete array is 0, then only we can get 2. So I am outputting 2. Otherwise I am checking for the odd case where I would be checking 3 cases. I found the smallest index, then the index just after it. And yeah, that was pretty much it. Like you can just add this assert to ensure that the XOR of the last segment will definitely be the required XOR. The press XOR, it should be press XOR here. It looks like there are some issues here. Some example is failing. Let me just check this. Mhm. Okay, this should be. Press your AI to R. Here I have taken press your right. Upper bound and infinity right. Like first segment, if it's more than R, we are not allowed. Otherwise, j is more than R, we are not allowed. And yeah, that is the solution I have. Not sure which case is it failing, but yeah, essentially this is the idea. Okay, sorry. It should be not. Yes, this works. Like instead of count, if count is 0, then print infinity. Otherwise, try to find it, and like this is the solution. Like we need one I, we need one j, and the remaining part after j would also have the required XOR. That was the solution for it. So any questions on this one before we move to problem G? And I would be back in 2 minutes. So if there are any questions, just let me know in this problem. Otherwise, I will move to the next one. Okay, I am back. Any questions on problem F? Okay. Can we check the next value of I in vector if it's less than R or not, which you have mentioned as it is? Yeah, like we can do it, but the idea would be like we would need one from right side, one from the left side. Like one thing which does not work here is like if this is the complete XOR, then if there are zero zeros here, and like basically from left to right fails on this test case. Like your idea, I think probably is find the first index where the XOR is 8 from the left side, and find the last index from where the XOR is A, right? I think this is what you meant, Pankaj, right? Then like whatever remaining areas will also be whatever XOR we need, right? The only time when this idea fails is this test case, and it is present in one of the samples. 0, A, 0. When you will try to find the segment from the left hand side, you will get this. And when you try to find from the right side, you will get this. And like this is not a valid division. And like so, yes. And here you might want to check like if this boundary and this boundary do not overlap. And yeah, that is the solution. Like in fact, like this idea was the first thing I coded, and it fails on only one test in the sample. 2 to 5. Like here is the test case. Or like I think one of the sample test cases is there, and that's where I came up with this idea. So this is problem F. I will move to problem G now. I have a solution for G1, and G2 is more like proof by AC. Either it will get an AC or someone will hack it. I don't have a time complexity proof for it. Problem, it says division plus LCP easy version. This is an easy version of problem. In this version, L equal to R. Basically, you are given a string S for a fixed k. Consider division of S into exactly k continuous substrings W1 to WK. Let Fk be the maximum possible value of least LCP of all these strings among all possible divisions. LCP is defined as like maximum common prefix for each of these segments here. For example, if string is AB, 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 C, AB, and K equal to 4, a possible division is AB as the first string, AB as the second string, ABC as the third string, and AB as the first string. Now, if you look at all four these strings, the first two characters are same for these values. So the answer in this case is 2 over here. And it says like in this version, like the number of segments is fixed here. So like this is one thing. Like asing on everything will come up probably later. Asing, I in fact used the JUD function there. So like let's make some critical observations here. Let the number of divisions are fixed. Let's call it A. K. So we want W1, W2 up to WK divisions. The idea is if these are the K divisions, let's say K equal to 4. And this green segment is the common prefix of length 3. And like, let's say this is the maximum possible answer. So my claim was we can binary search on this length, because if a solution for length 3 exists, then solution for length 2 also exists. Like, take first 2 characters. Like, basically, we can write a binary search like question is, does there exist k divisions which have more than, like, basically, let me formulate it again. I will binary search on the number of equal characters. So I will have some L, some R, and some mid. I will ask a question. What is the maximum number of divisions I can get if first mid characters are same? If the answer to this question is greater than equal to L, if the answer to this question is greater than equal to K, I will assign L equal to mid. And if it's less than R, I will assign R equal to mid. So at the end of the day, when my binary search terminates, I would know the exact number of characters where there would be at least L segments of the required length. And now the question is like, how do we answer this question? What is the maximum number of segments if first k characters are common? We can use greedy plus hashing. We can first take the hash of first mid characters. So I start with I equal to 0 to n. I check if the hash of string si to plus mid minus 1 is equal to required hash. If it is yes, I do count plus plus and I assign I plus equal to mid. Basically a jump. Like, now I should grid idea is greedy. Take the string. If the first mid characters are equal to mid, you increase your count plus 1 and you remove it. Otherwise, you insert the current character into the previous segment we had and you keep continuing the part. And like, this is how I can greedily try to find like what is the maximum number of segments I can get if first mid characters are equal. And then I can compare that result with my given length and try to binary search on it more. And like, this is essentially the idea. Hashing is one way to do it. Z algorithm is another way to do it. You can probably also use probably suffix array etc. to do a suffix automa. Like, all of these are doing nothing. but they are comparing like is S0 to mid equal to S I to I plus mid. And just there are some fancy ways to do all of this stuff. Suffix is suffix array. Hashing works. In fact use Z algorithm. Like Z algorithm takes the string S and it gives us like how many characters are equal to the starting prefix for each of the starting index I. Z is the length of longest string that is at the same time prefix of S and a prefix of the characters if you start taking characters from the ith index. The KMP might not be trivial for this one to get the result back. Although like any problem which is solvable using KMP is also solvable using Z function. And if something is solvable using Z function, it's also using solution. Because if you know Z function, you can definitely calculate KMP and the other way around. Like there are algorithms like whether when you know. So if any problem, okay, 1 second. Yeah, you are given a Z function of some unknown string, write prefix function of it. You are given prefix function of some string S, write Z function of it. Without knowing the actual string, with those two values you can find, like these are essentially the code here. So like if something is solvable Z, it's KMP and vice versa always holds true. And like I will jump onto my code for G1. Like I would be taking the questions from the chat once I'm done with both the problem. Any questions related to this contest, any other contest? Like I used this as a black box. I took string S as input. I computed Z function. So for each string, I know how many characters are equal to the first current character there. Like get max segment count. This is the function which takes the given length, which will generally be equal to mid. If length is equal to 0, I would say I can create infinitely many segments. It's not really required. Otherwise, I start from I equal to 0 while I less than n. Like I will probably start with n because for let's say zn equal to n plus 1. If zi is greater than equal to length, let's increase our count plus plus and let's make I of length n. Otherwise, let's append current character to the end of whatever character we have. This function gives me what is the maximum segment I can get if I want all of them to have length equal characters there. Now I have some k. I want to find the max length over here. So like binary search minimum length possible. Like it's always possible to get 0 characters, and it's impossible to get n plus character equal. Binary search mid. Count how many segments I can get if I want min. If this is equal to my required k, I is mid. Otherwise R is mid, and I return L and get length L is my solution for this given L to R because there is only just one value, so I can directly find and print it. So this is the solution for G1. So like I probably like let's ensure that Z0 returns. I'm not really sure what the default is. Like default it returns Z0 equal to 0. So like this is the solution for G1. Now how to solve G2? Like I had two ideas, both of them gave an AC, but I don't have really any proof why it works, and it's possible someone will hack it later. So I will just say what I coded in the contest, and pretty much that was it. The idea is I have L, I also have R. I first count what is the length of common string, get length when I want at least L segments. Then I also calculate max R, max count using this function. Like how many maximum segments which I can get with max length for the given length. Now you can notice for everything between L to max count, the answer is len. So I first computed the length for L and what is the maximum number of segments I can get using length. And then I directly wrote using a simple for loop that answer for all of these j would be length. And I did L equal to max count plus 1. Now try to do repeatedly try to find the next part. This was one solution which did give an AC, but there is at present I don't have any really proof why it runs within the given time window. And it's very much possible that someone will hack it. While L less than equal to R, find the length for L, find the next possible R for the given segment, print length that many times, L plus plus, and then try to find the next again, keep doing it. This was one way to do it. And like the other way was pretty much building up on the same part. Like we have L, we have R, which is the length. Let's also try to find mid. So if get length L equal to get length mid, assign it to everything. So basically recursively solve for all the length. Solve for L to R. If get length L equal to get length R, answer for all L to R is whatever length I got. Otherwise find mid and solve for L to mid and solve for mid to R and keep doing this. And like that was the other solution, which is pretty much doing whatever I did in the initial part. Like both solutions are equivalent and time complexity of both of them would be approximately same with some constant factor. Segar, if length of both of them is same, assign everything with the current segment return. Otherwise, if it's less than 2, fine. Otherwise, find the mid and solve for mid and both the parts separately. And like that is the other solution I had. And like this pretty much completes my stream for today. Any questions or any problem or any other question before we call it a day today? Like I will wait for 2 4 minutes more for any questions related to contest. After that, I will try to answer questions from the chat. Like in fact, one of the thing I did was instead of taking mid, I just took random value between L and R. just to make it slightly more difficult. Randomly between L to R is made, and Reddit can keep doing it. In fact, this also gave an ACB. Like we can probably prove that the on average the number of iterations with random would be twice of what we would get with L plus R, something like that. But like at least within some constant factor, taking mid as L plus R and taking mid as random value from L to R would be same. So like this is what I did, and I would be happy to hear some other ideas from different people as well. Okay, questions from the chat are: could we improve without learning new topics? I won't say like that's not possible. Like I would say like you should definitely learn new topics if you want to improve. Because if you don't learn something new every now and then, like then you would struggle with whatever knowledge you have. But to take an antidote of it, like the way to do it is not learning new topics, rather solving new problems should be the better problem question. Like, can we improve without solving some problems every day? The answer is no. And when you solve some problems every day, you will definitely learn new topics on the fly. And that is how I used to learn. So if you just keep learning topic, then even if you learn 1,000 new topics every day, you would not improve. But if you are on the other end, like whether I will not learn new topic and I will try to improve, then the answer is no as well. You definitely need to solve new problems every day. And when you are solving those new problems, you will learn something new while solving those problems. And that is how you are going to improve. Okay, so probably Vidya, you can probably contact me on LinkedIn once for the thumbnail template. And like I think there was one more question in the chat. Yeah, I want to start doing CP but not done with DSA. Is DSA basics of it or it's different? Like generally when DSA versus CP comes up, my only question is like what are your goals? And like if the goals are like you probably want to get a good placement or something like that, then like basically what are your goals and how much time you have. So if someone says they want to find a new job or internship in within next 6 months, I recommend them to solve lead code rather than code forces. But if you have let's say a year or 1.5 year or so, then I advise if you are just a beginner, start from at code a beginner contest, and you can also keep doing code forces along the way. And I think I will probably add the answer to these questions in my most FAQ chat on the Discord server. Like the Discord server's invite is in the chat. Like here, I have a clickbait channel roadmap to read in 2 minutes, where I generally advise people on what they should do on different things over there. So like most of the questions you have might be answered here. I mean that maybe if I just solve problem, I will improve my creativity. Yeah, like that is how I used to do. Like I used to solve problems, and if I am stuck on a problem and I found new topic on it, I used to read blogs, watch videos or something on the topic. And like the other way to do is like just keep reading some textbook and without coding anything, and that's a no from my side. Keep solving problems along with improving your creativity. You will definitely learn new topics when you end up knowing how to solve that problem, and that is the way to go. Just ensure that like the problems you solve are not way too easy for you. Like if you find problems easy, then push for solving some harder problems. Like for example, if you are consistently able to solve due to C problem, then in your practice you start solving due to D problem. Some people also try to look at problem rating to increase the rating, and like anyway works. But yeah, from my side recommendation is keep trying new problems every now and then, and along with those new problems you will definitely learn new topics which you have not encountered, and you can learn that along the way. And that's how essentially I did when I was actively practicing. So like any other questions from the chat before we call it a day? So if there are no more questions, then like Then if there are no more questions, then I will probably call it a day today. Like it's a long stream today. So thanks everyone for joining today. I am currently pupil. What do you suggest? Like the first suggestion I have is to join Discord and check like what I have already suggested. Like Discord server invite is in the problem description. Like a lot of people ask me what I did to reach 18x. Then like this is what I did when I was less than expert. So you can directly write it, and if there are any questions on it, you can probably ask it on Discord as well. And probably it's good night time in India, but that might not be the time in other parts. Yeah. Like maybe try promoting everywhere possible. Like the only problem of like I do want to promote it, not that not promote it. But if I do it aggressively, then a lot of people will join it, and it may not be possible for me to moderate in starting. Whether if the growth is relatively in small steps, I can get new moderators and try to get everything. Like the problem which I have in the server right now is like a lot of people have questions on how to they debug a particular problem or they are stuck somewhere, but it's not physically possible for me to answer everyone's possible doubt or debug for them. So if more people help out each other, then that would be the way to go. Like some people do ask like how do they solve a particular stuck, or like they share their submissions. So the way to grow it would be like it's in the chat by the way, like or I can probably type it here. Like you can visit this website and get it, yt403.com, and you can find community server link here. Or like it's even in the description as well. So like probably like this is the link, or you can find it here. And thanks everyone for joining today. I think I will end the stream now.